So covariance, why this concept we have to learn in the machine learning theory? So let's discuss this concept through an example. Suppose let's take we are doing an experiment that we have interest to find the height. X is a random variable, that's our height of the students, the heights of the students, and y is random variable, that is the weights of the student, weights of the students. Now our job that we have to do, we have to find its observations, and to collect the observations we have built this kind of data set. Suppose let this is our structure of the data set. Here the random variable x is equals to height, y is the random variable, it's the weight w, and this is the first student, student 1, this is for the student 2, this is for the student 3, like that. And suppose let's take we have find such kind of n observed value for n students. Suppose let's take its value is x1 and corresponding value is y1. Let's take x2, corresponding weight is y2, x3 corresponding weight is y3. Let's take its xn and corresponding value is yn. Means we have calculated, we have compute these height and weight for each student respectively. Okay, no, I am not counting these values as like that. Means first I have count the height for each students, and randomly I have first count the height randomly for n students. I have first count the height, then after that I have randomly select the students, and I will compute its and find its the height. Wait, I'm not doing these jobs. I am taking one student, and for this one student I have find its what is actually its height and what is actually its weight. I am doing these two jobs parallelly and build this data set. I'm not doing this job. Okay, I'm not doing this job. Now the second thing that we want to get the answer. So now these two random variable x and y, means height and weight, are what is the relationships between these two things? What is the actual relationships that we are interested to find its answer? What is its actually relationship? That's we are interested to find. So the questions that we want to get its answer, what is its relationship between these two random variables? Between x and y. Now there may occur two type of answers. It may be first, it may be if x increased, then y increased. This may be, or there may occur if x increased, y decreased. So there have only two possibilities. Any of the possibility may occur. So let's see how we will find from this data set, how we will find this relationship. Let's see this thing. So to get the answer of such questions, so first that come into the picture the covariance concept. Covariance concept. Okay, that, and there also have some drawbacks of this concept. So to develop this covariance concept, we build the thing that is we have built the theory that is called the Pearson correlation coefficient concept. Pearson correlation coefficient concept. we will build this thing, we will build this theory. Now also there have some drawbacks for this theory, and now using some techniques, using some development on this theory, we have built another theory that's called the Spearman rank correlation coefficient concept. The Spearman rank correlation coefficient. This concept. So we will discuss each theorem in details step by step. So first, now some we have developed something, then we have reached here, then from here to here. Now let's first discuss the covariance. Then in the next lecture we will discuss the Pearson coefficient, and then we will discuss Spearman correlations coefficient. Now let's see what is actual covariance concept. Not only in mathematics point of view, let's see these things in geometrical point of view. So let's see. So first see the what is correlations. Means we are interested to find the correlations in this random variable, means in these experiments, means in this observed value of these experiments. So let's see. So the covariance that's written in short COV of the random variable x and y, its simple mathematical formulations is so simple. We have to take the average value. This is the simple average, means we have how much data points, n number of observed value. So we have taken the first mean of that observed value. Now how we will take this mean? First we have to take the differences for x, each observed value of the x minus its mean of the x, into we have to multiply these things minus mu of y. So this mu x is the mean of the random variable x, and this mu y actually is the mean of that random variable y. Means I am talking about mean of that random variable, means the mean of that observed value. Okay, so this the observed value of this thing. Mean observed value of these things is actually mu x, and mean of this observed value is called the mu of y. Okay, this is the thing. And now individually we have to make the subtractions and then build the multiplications of this. That's the thing that we have to do here. Okay, this is the simple covariance, the formulations of the covariance. Now let's try to understand this thing in geometric point of view. Now one thing that before going to the geometric portions of it, now let's try to understand these things. So here we have two different variables x and y, but instead of taking the two different variables, if we take the same variable, so if you just compare between the same random variable, that's thing, instead of calling it covariance, we call these things as simple variances, VAR. Simple, it will be x. So these things will be variance of 1 by n minus I is equals to 1 to n, and instead of taken y here, we are taking here x. So now this formula now comes into mu of x, and instead of taken y, I am taken here x. So it will be square term. It will be square, means multiplications of xi minus mu of y. This is the simple variances. This is the simple formula of the variances. We have already seen this thing. This is the simple variances formula. Okay, just it's come from here. Now the variances is and the covariance are both the same thing, and variance applicable on its single random variable, and the covariance are applicable on the different random variable to find relationships of the two different random variables. Okay, now let's see the thing. Now let's see the relationships actually. So we will see these things in geometrical point of view. Now let's see these things in analytically. So the covariance of x and y, it is positive. If these things is positive, then the relationship is, if x increases, then y is also increases. This is the first relationships. If after calculations we got this covariance value is positive, then these relationships hold. And if covariance of x and y is negative, then the relationship will be, if x increases, y will be decreased. This is the second relationship. So this is the simple value. If we have to calculate it, if we just calculated these things and if you got this positive value, then these relationships happen, and if you got the negative value, then this relationship will happen. Now let's try to understand these things in geometric point of view. Okay, suppose let's draw the diagram first. Let's draw the diagram first. Suppose let's take the x-axis is for x random variable and y-axis for y random variable, and our data sets for these random variables are actually look like that, this type of data sets. Suppose after plotting some scatter plot on our data set, suppose look like that, we have got this kind of data, this kind of scatter plot for our data. If we got this kind of relationships, if we got after scattering plot, suppose let's take we got this kind of data set, this kind of data we have. Now if you just see here, suppose let's take our random variable, the mean of this x random variable, suppose let's take the mean for this is here, mu x is here, the mean for the random variable y is look like here, something here, mu of y. Okay, now let's first calculate it. First what actually our formula. Now it will be better if we just write down here the formula or side by side, then it will be best for us. So already we have seen our covariance. The formula of the covariance is, first we have to take the averages 1 by n, then we have to take its summed value, then these things will be xi minus mu of x into yi minus mu of y. This is a simple formula of our covariances. Now try to understand this formula through this geometric perspective. Suppose let's take we have the data point. First we have the data points. Data points is lies on here. Suppose let's take our data point is x1 y1, that's lying on here. Now the x value for this point, the x value are lies something here. Suppose let's take it's the x1, and the y1 value are here, somewhere here. Suppose let's take it's here somewhere. Now if you just see these things, x1 and y1 both are the larger from our mean mu x and mu y respectively, then if you just calculated these two things, then for x1 and y1, what will be the value of xi minus mu x? First we have to compute this value, then we have to compute yi minus mu of y. If you just compute these two things, first what for this point, what will be the value for xi minus mu x? So this value will be for this xi minus, its value will be positive, as well it will be positive. Now if you just multiply and summed up and taken the averages, means after multiplications taken the averages, positive summed, the average of the all positive value, it must be positive. So the covariance, so here covariance must be positive. Okay, now the second point, let's take our second point is look like here, somewhere here. Okay, let's take somewhere here about second point. So for these points, suppose let's take this point is x2 y2. Let's take this point is x2 y2 here, so it is our x2 point and y2 is somewhere here, so it's our y2 point. So for this x2 and now for this x2 and y2 point, what will be the subtractions? Means x2 minus mu x, what will be this value? So this value will be negative, and also this value y2 minus mu y, this value also be negative. If we multiply these two things and taken its average, if you multiply negative into negative, it will be positive, and the positive, the average of every positive, it will be positive. But the difference is, suppose now let's take another point, it will be better for us. If we just suppose, let's take, I have taken here the next point here, the point is x3 y3 here. Okay, suppose here it will be somewhere here x3 value, and somewhere here it is y3 value. Okay, so for x3 y3, so what will be these subtractions? Means x3 is smaller than mu x, so it will be negative, as well y3 is also less than the mu of y, so it will be negative. Now multiplication of these two negative values, it will be positive. So positive, and the average value of the positive number is also positive. So we will see this thing in each cases. In each of any of these three cases, our covariance value must be positive value. Now the question is that, sir, how much positive it should be? Just see this thing first. xi and yi, x1 and y1, it is much more distance. Its distance from the mean is much more. So the point that are much more distance from the mean point, so this value will be larger. This value will be larger value, because this x2 y2, see this x2 y2 value, these value are more closer in our mean, is around in our mean. So those points those are around in our mean, so this covariance value much smaller. And as well for x3, it's lie on the negative side of our mean value, but its distance are further from our mean, so also it's a larger covariance. So now from these pictures we will conclude that, so it's the covariance value. The covariance value are depend on the mean. So covariance will be smaller if our points lie on our mean value. It will be larger that if it lie on the positive side of our mean value, as well as if it lie on a mean negative side. If it positive, further if we increase the distance from our mean of our data points, then its covariance is also increased. If we increase the distance from our mean from the negative sides, as well its covariance value is also increased. So if our data sets are look like that, means if from this data set what we will get the relationships, from this data set we can conclude that if x increased, if our x increased, if random variable x increased, then as well y is also increased. Y is also increased. For this kind of data set, covariance of our x y will always be positive. I think you have understand this from this case. Now let's discuss the another cases. The another cases was look like this type. Suppose let's take, this is our scatter plot, and this is the x random variable, and this is the y random variable. And this type of scatter plot means now I am going to discuss the relationship like that. If x increases, then y value means y decreases. Now If these things are happen, means our now scatter plot will be look like that, this type. If x increases, y is decreases, look like this type of scatter plot. Here we have got this type of scatter plot from this, because if we got this kind of scatter plot from our data set, when x increases, means in this direction x increases but y decreases, just say this thing, y value decreased but x value increased. In such scenario, what will be the covariances value? So suppose let's take as similar, suppose let's take here is our actual mean point is look like here, somewhere here, mu of x, mean value of y is will be lying on somewhere here, let's take mu of y. Now first take one point, suppose let's take first point is, and we have to calculate the xi minus mu of x, and after that we have to multiply this thing yi minus mu of y, and after finding calculate this we have to calculate its covariance. Okay, now let's discuss step by step, one by one. Suppose let's take first value I have taken here, this here, suppose let's take here insert further away from here, I am first taken the value that x1 y1, first point let's take, and its corresponding y value will be look like here, somewhere here, it's the x1 and it's the y1 value. So just say this thing, x1 is greater than mu of x. If x1 is greater than mu of x, this means what? This means this value is what? X1 is greater than positive value. Now for the point x1 y1, positive value, but y1 is less than mu of y, this means what? This means this value is negative value, and if you multiply these two values, then you got that negative value, and the if you just summed up negative value and take its average, you will get its covariance value is negative. Suppose let's take we have taken another value from here, x2 y2, x2 y2, like from here, somewhere here, means here is our x2 value and here is our y2 value here, somewhere here. So if you take such like of point x2 y2, so x2 is less than mu of x, this means this value, if you calculated the x2 minus mu of x, this value will be negative, but y2 is larger in our from our mu y, so this value will be positive. If you just say multiply these two things and calculate the covariance, this value will be negative as well. So same things also near about the same things. If you take on the value closer to our mean, the covariance value will be smaller. If you take on the value that are larger from our mean, from the means farther from our mean, so the covariance will be increased. So if you take on the data points that are closer to our mean, the covariance value will be smaller. If we taken the data points that's further from our mean, as well negative or it will be positive directions, then the covariance value will be more larger. Okay, I think you got the concept. So in such scenario, in both the cases, we will got the covariance value is negative. Okay, so in such cases, in these cases, we got that our covariance of x and y is negative. Then if covariance value is negative, then we will conclude that our data sets are maintain these relationships. But in these relationships, they have and drawbacks. So now let's discuss what is the drawbacks of this covariance. So what is the drawbacks? What are the main drawbacks of these covariances? Suppose let's take we are find the covariances the two random variable x and y. Finding that we are interested find the covariances of x and y, and x1 and x, that's the height That's actually the height. That's the height of these random variables are taken in centimeter, and the weight y means the weight of the students that's taken in, suppose let's take, we have measured these two random observations of these two random variables, a height in centimeter and the weight in kg, and we have calculated some covariance of it, means x is here calculated in centimeter, and y have calculated in kg. Now we will just simply convert this data set. Now we will simply convert this data set, taken another. Now we will simply convert this data set to x is now converted, the height is now converted to the, suppose let's take in feet, we will convert this centimeter to feet, and we will convert the y means weight in pound, means lbs in pound. Just we simple the measure, convert the data from centimeter to feet and weight to pound. Now if you calculated the covariance for these two random variables, suppose let's take I have this x dash, after conversion this value is x dash and this value is y dash. Now if you calculated the covariance of x dash and y dash, then both are the same kind of data, just I am convert this data to this data, centimeter to feet and kg to pound, but the covariance is for, means this covariance is ft, this covariance means lbs. So this covariance might be, should be same, but the main problem is here these two are totally different, means these two are not equal, actually these two not unequal, these are the differences. These things are the main drawback of the covariance, because we have the same data, just we have convert this data from centimeter to kg and feet to pound, but we have seen that our covariance have changed from here to here, from here to here. So this is the main drawback. So in the next lecture we will see how to solve this problem, how to remove this problem that we have faced here to calculate the covariances. We will see these things, and by simply using the Pearson correlation coefficient concept, we will remove this problem that we got to calculate the covariance concept. Okay, that thing we will see in a next lecture.